Winter is winding down. I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast, the week starting Sunday, March 20th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Looking at significant wave heights for the North Pacific Ocean, we see remnants of a gale north of Hawaii, generating 22-foot seas aimed south. Swell is on the way to the Hawaiian Islands and the U.S. West Coast. You also see an area of seas off the California coast being generated by local wind, lots of chop, lots of wind, typical springtime sort of conditions. And then a low, pretty much just pushing into Kamchatka, not generating any meaningful fetch at this moment in time. Let's get into the details. As usual, we'll start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales when they form, help direct their track. We're looking for a trough, that is a dip in the jet, like right there. And what that helps do is create a counterclockwise flow aloft and down at the ocean's surface. That's the hallmark of low pressure. And low pressure, if it's deep enough, generates winds. Winds, if they're strong enough, generate seas. Seas, as they radiate away from the fetch area, eventually turn into swell. And swell, when it hits your beach, turns into surf. So before we get into this particular frame, we actually got a question from one of our viewers, I think it was last week, and they wanted to see a visualization, maybe an overlay of how this actually works. So we built one. Not great, but we have something to show. So here's a trough. This was Saturday, just a day or so ago, Friday evening, a day ago. Here is another trough from, just a couple days ago. And the low pressure you'd think would be situated right there. So now let's go take a look at a surface level chart and see what it's showing us. And here's the surface low, right where the trough would be. We'll click back. Let's see if we can get to, there's the trough, and then there's the low. So the trough, let's see if we can go back here. The trough sets up the upper level circulation that works its way down to the ocean's surface, that in turn is manifest here at the surface as surface level pressure and surface level winds to set this low, create a circulating counterclockwise. All low pressure systems in the northern hemisphere circulate counterclockwise and generate, in this case, 45 knot winds. And so then the question was, can you build an overlay showing the both of them at the same time? Well, I tried that. I mean, it's not great, but you can actually see the jet stream here doing this and then coming down like this. It's barely visible underneath, and I tried to set the transparency so you could see it. But then right here, here's the jet, and here's the low, nestled perfectly in that trough. And then there's even another little trough here that's supporting a low, and another trough here that's supporting a low. And you can kind of make that trough out here, the main trough here, and the secondary trough here. So the upper level dynamics, or the upper level winds, is what drives everything. You might wonder, why do we care about the jet stream? Why do I spend so much time talking about it? Because if you don't have troughs in the upper level, you're never going to get a low pressure system down at the ocean surface. And if you don't get a low pressure system, you're not going to have significant wind. And if you're not going to have significant wind, then you're not going to have a swell generation source. And so it all starts in the upper level of the atmosphere. I hope that was helpful. All right, so back to this week's image. There's a trough again over Kamchatka, another trough here just in we'll call it the Western Gulf, and then a ridge, the exact opposite. The rising air like this, or pushing north, creates a clockwise flow down at the ocean surface, and that's high pressure. That's what's generating strong north winds along the California coast at the moment. All right, moving forward. So we get into Monday. The trough continues in the Western Gulf, but starting to get pinched. Another broad, mostly landlocked trough continues over Kamchatka and the Kuril Islands. We get into Tuesday. Now the trough here actually starts to broaden. There was this, let's go back. You notice the jet was actually split or breaking up, pushing way to the north, part of the flow up here, part of the flow down there. Now we're into Tuesday, notice that split just peels off and disappears, and all the main energy starts focusing on the northwestern Gulf of Alaska. And by the time we get into Tuesday night, we have a pretty well-defined trough here in the Gulf of Alaska, being fed by about 180 knot winds there over the dateline, looking pretty good. And the trough continues, sort of easing off, not as much wind supporting as we get into Wednesday night and Thursday. But then as we get into Thursday night, the trough reinvigorates yet again with, let's go back. There again, 1, 2, 3, 4, that's 170 knot winds feeding into the trough. So more support for gale development there, okay? And that trough starting to pinch off Friday night, and then pretty much fully pinching off as we get into Saturday. But notice, still present with a tight little trough off the California coast as we get into Sunday, nearly a week out, and then pushing into the coast, perhaps bringing some moisture there. And then even behind that, a reasonably decent looking jet stream flow aloft. No clearly defined trough shale, a little bit of something in the northwestern Gulf. A little bit of a split going on here with some energy pushing south of Hawaii. But all in all, given the time of year and given just the year that we've had, this isn't a horribly bad pattern. All right, so let's go take a look down at the ocean surface. Surface level pressure, surface level winds. Surface pressure and wind right there. All right, not unexpectedly, low pressure over Kamchatka, not really doing anything. There is this little remnants of a gale previously that was over the dateline, still producing almost 40 knot winds aimed due south at Hawaii, and we'll get into that in a minute. Swell is pushing towards the Hawaiian Islands and the U.S. West Coast, and remnants of that gale start lifting north. Our forecast to redevelop as we get into Monday with a tiny area of 40 knot winds, maybe 45 knot winds, spraying over an area somewhere here along the Pacific Northwest mainly, but quickly lifting off to the north, not doing a whole lot. After that, a little bit of a fetch in the northern Gulf as we get into Wednesday night, 30 knot winds, but that's not really of interest. It's this system on Thursday that starts developing off Japan with 45 knot winds, pushing over the north dateline region with, again, a built-in area of 45 knot winds. On the dateline Friday night with 40 knot winds aimed well off to the east, and then starting to fade as we get into Sunday and theoretically falling south and maybe starting to rebuild. We know there's a new trough forecast in this area as we get approaching Monday. That's a week from Monday. So we'll just have to wait and see. And notice 2 more systems behind that sort of taking the high road over the north dateline ridge and maybe falling into some sort of a trough system off of California. Way too early to know for sure, though. Never trust the models a week out. Maybe 3 or 4 days, maybe a week gives you a rough idea of what's coming, but don't ever take it, assume that exactly what the models say a week out is really going to happen. All right, so now we're going back into time to Thursday evening. This was just a couple days ago. A gale started building. The dateline, international dateline right there. Northern California, Central California, Hawaii there, Japan there. Seas building, 25 feet, the highest seas over this whole domain, and clearly that is the highest seas, so we know that's good. And then it's sort of a strange system breaking apart, redeveloping with 26, maybe 27-foot seas on the dateline, and then, again, still 27-foot seas pushing southeast, aimed well at Hawaii. This was on this morning, and still falling south as of right now. So swell is in the water, certainly radiating towards Hawaii, maybe small energy to California, but lots of wind swell probably for California, might even mask the, most of the swell. We'll see. So we get into Monday, that system fades out, and then tries to redevelop in the northern Gulf, small area, 25-foot seas in the northern Gulf. Again, maybe a smattering of swell trying to push into California. You can see literally a front of energy pushing into Hawaii on Tuesday evening and then bound for the U.S. West Coast sometime on Wednesday. Really a function of how much chop's in the water as to how much you'll see the swell north of Point Conception. And it'll probably be too small in Southern California to really matter at all. Again, low pressure tries to start redeveloping the Gulf of Alaska, not doing much on Thursday. But a new system starts building Thursday night off of the Kuril Islands, pushing over the northern dateline region with seas at 34 feet and holding there into Friday night, then falling southeast as we get into Saturday, but also dissipating some. But then we know some additional fetch, and you can see it here starting to build with seas in the 19-foot range, starting to take hold, almost giving you a hint that maybe something good, teasing us that something good's coming beyond. Not going to hold our breath, but something to maybe look forward to. Looking at the wind forecast for California and Hawaii. Hawaii in a great situation, light southeast trades, no big deal. High pressure off the California coast, the wind machine, springtime wind machine in full effect. 25-knot north winds along the entire California coast down into Mexico. Just a real mess. Yes, generating wind swell if you got some protective cove, that's protected from the north wind. Yeah, there's waves. It's not great. It's still wind swell, soft and pretty gutless, but there are waves. Monday, pretty much the same thing. Maybe the gradient fading a little bit. Notice a little bit of a new high-pressure system building here for Hawaii as we get into Tuesday. And then as we get into Wednesday, still this north wind pattern for California, but much mellower than what we're seeing today. Wind swell still being generated. Trades pick up for Hawaii, though. 20 knots out of the east-northeast. And continuing for Hawaii through the day. So we get into Thursday, still a pretty raw, strong trade wind pattern for the Hawaiian Islands. Lighter winds for California as low pressure starts building in the Gulf of Alaska. On Friday, still north winds for California, 15 knots off the coast. And still some pretty strong trades for the Hawaiian Islands. And then as we get into Saturday, finally the wind machine breaks for California. That's a good thing. Certainly not for Hawaii, though. The springtime La Nina winds come home to roost for the Hawaiian Islands. Continuing into Sunday, California, you see low pressure starting to build just a little bit off the California coast. South winds take over. And let's see where we go. And still low pressure. I mean, this is good for precipitation, potentially, if you believe it. We'll take whatever we can get with yet a broader low pressure system, theoretically building in the Gulf of Alaska, 30 to 35 knot fetch over, over a pretty good size area. I was going to say 1,000 nautical miles. I think that's probably a little bit overstated. But still, potential for swell generation, if you believe the models. All right, so let's go take a look at rainfall potential for California. California right there, high pressure in control. Lots of precip for, we'll say, Washington northward, but nothing getting into California. We're into Tuesday, Wednesday, nothing. Thursday, nothing. Friday, Saturday, and then that low pressure starts building Sunday off the coast. We already see a little bit of snow for the mountains. Precip from even down into Southern California, we'll say Santa Barbara County, up into Point Arena and maybe beyond. And we'll go 180 hours out, and almost the entire state of California has some level of precip and snow. It looks like it's a warm event with snow only for the higher elevations of Tahoe at this early date, but we'll keep our eyes on that. Snow forecast dashboard for Squaw Valley, Olympic Valley. So this is actually out 10 days, and it's about 7 inches, something like that. So this event that starts on the 27th is forecast to continue a little bit into the 28th, early the morning of the 28th, and maybe a little bit of snow. Let's go check some other locations. Kirkwood less with maybe 4 inches, 5 inches, something like that. And Mammoth doing okay, about 5 inches or so. So potential for everybody. Back to Olympic Valley. Now notice temperatures, the freezing level. The elevations are here going from sea level up to 14,000 feet. The red line is for sure liquid precip. That's temperatures at 34.6 degrees or higher. The gray line, sleet. And where the white starts, that's the 32 degree, the freezing line. You can see the freezing level going up to 12,000 feet in tomorrow afternoon. So pretty warm and effectively holding somewhere between there and about 10,500 feet almost the whole way through the week till the 26th, and then crashing on the 27th, but not as low as it was even the last run of the model, now down to only 7,000 feet. The last run of the model actually had it down at 4,000 feet or something, and more snowfall than what was predicted here. So the models, you can see every run having a bit of a hard time, and it's a week out getting a grasp on exactly what's going to happen. But then theoretically a warm-up after that, and then cooling down. Springtime, typical springtime pattern. Big changes in temperature from cool to warm to cool to warm until eventually you get to the point where it just stays hot all the time. The good news is that you get good corn snow. That can be a lot of fun until there's no snow at all. All right, let's go take a look long term what's going on. We've looked at the 1 week forecast. Now let's go out 2 weeks, 3 weeks, a month, a year by looking at the Madden Julian Oscillation. That'll give us maybe our 1 month forecast, and then the El Nino Southern Oscillation Index, that will give us, or the El Nino Southern Oscillation, that will give us our view out maybe as far as a year. So we're going to start by looking for signs of the MJO, the Madden Julian Oscillation. There's 2 phases to it, the active and the inactive phase. The active phase is on one side of the planet, the inactive phase on the other. They rotate on the equator from west to east. So the active phase or the inactive phase would first show in the far west Pacific and then work its way across the Pacific into the East Pacific, south of Mexico, and then out of the Pacific, continue around the planet over the Atlantic Ocean. The active phase is effectively a low pressure system. That low pressure creates clouds. It also dampens trade winds. That's a good thing. And it also imparts energy to the jet stream. All right, so first stop here, we're looking for winds on the equator. This is data from the TAO buoy array, a series of buoys strung across the equator in the Pacific Ocean used for monitoring El Nino. But it has wind sensors on the buoys that we can use to monitor the Madden Julian Oscillation as well. This is the East Pacific here. This is the West Pacific here. The equator right there. New Guinea is right there. 100 west, so that's roughly south of Mexico. We're looking at the arrows. They show wind speed and direction. The longer the arrow, the stronger the wind. So wind's pretty strong out of the east in the East Pacific, quite strong over the Central Pacific, quite strong in the West Pacific. Oh, by the way, that's the date line right there. The Kelvin wave generation area, that is when the active phase of the MJO moves into the West Pacific, so basically just north of New Guinea, and starts making its way across the Pacific to about 170 west, right there, 5 degrees north and south of the equator. When it moves into this area, because it's a low pressure system, it dampens trades, and you can see the speed of these trade winds will start to decrease. We don't see any sign of that today. But it's not the actual wind speeds, it's the anomalies, differences from normal for this time of the year. That's what really matters. So looking at that, you see, yeah, the winds are pretty strong in the East Pacific, but looking here, they're all pushing from the south. There's no east-west component of the wind at all. So basically, neutral anomalies. Even over the Central Pacific, pretty light. It's only when you get into the West Pacific, the Kelvin wave generation area, that winds really start getting strong out of the east. That's a clear sign of the inactive phase of the MJO, a high pressure system, the opposite of the active phase of the MJO, the evil twin of the active phase, the one that doesn't feed energy to the jet stream, that suppresses storm development, sets up high pressure, and does nothing for enhancing precipitation over the Pacific. If anything, it dries things out. All right, let's dig a little deeper. So we'll go to the 1 week forecast. All right, now this chart looks a little weird. It's the whole planet on one chart. So first off, you have to go, well, where's the Pacific Ocean? Pacific Ocean on the equator starts at 135 east, so right about there. Just go right up the chart. And then it ends at about 80 west over here, so that would be like the Galapagos. But we don't care. What we're really interested in is the West Pacific, the Kelvin wave generation area, because that's where when the active phase moves over the West Pacific, it does its magic. That's where it pumps energy into the jet stream and where it also can create Kelvin waves by reversing, at least suppressing trade winds, if not out and out reversing them. And I say that with purpose this evening because you can see a clear shift in pattern getting ready to set up. The blues and purples are easterly anomalies associated with the inactive phase of the MJO, but when they're over this long a period of time, like a month, that's more indicative of La Nina. And you notice how when we get 2 days from now, all of a sudden the purples start disappearing and you start seeing yellows and reds. Not a lot, but it sort of indicates that at least the inactive phase of the MJO, if not La Nina, is going to lose its grip a little bit and west anomalies start taking over. Maybe the active phase of the MJO starts setting up. We've been looking for this for a very long time. All right, outgoing long wave radiation forecast. Just fancy words for cloud cover, but we said the active phase of the MJO is like a low pressure system. It generates clouds. The inactive phase, like a high pressure system, it doesn't generate clouds. All right, so here is a forecast that goes out 2 weeks, 15 days, 0 days, 5 days, 10 days, 15 days. All right, we look at each panel here. There's South America, Peru there, Central America, Hawaii, New Guinea there, Australia, EQ, the equator right there, the dateline 180 west, the Kelvin wave generation area right here. This is what we're interested in. The yellows and reds mean a lot of sunlight reflectivity off the ocean surface, meaning no clouds, meaning high pressure, meaning the inactive phase of the MJO. Now this is from the statistic model. Notice 5 days from now, that high pressure system starts breaking down. And even more so 10 days from now, while this low pressure system, this cloudy area that's over the maritime continent, Bali being right about there somewhere, starts moving west into the West Pacific, and 2 weeks from now, fully taking over the Kelvin wave generation, indicating the arrival of the active phase of the MJO. That's great. Now, this is one model, the statistic model. The dynamic model says basically the same thing, but you notice the active phase not as strong upon arrival in the West Pacific as the statistic model. So a little bit of ambiguity here. Again, don't trust a model 1 week out, much less 2 weeks out, but something to look forward to. And when you're desperate, you'll take anything. Phase diagrams, just another drill down of the same data. Statistic model here, dynamic model here. How do we read this chart? Well, first off, there's different phases, 1, 2, 3, 4, 5. They're just geographic locations effectively over the Earth. The MJO moves from the Indian Ocean, so somewhere between phase 2 and 3, to the maritime continent between phases 4 and 5, over the West Pacific between 6 and 7, to the East Pacific, under the United States, across the Atlantic, and then back to the over Africa and back to the Indian Ocean, restarting here in phase 1 and 2. This is sort of the generation place of the active phase of the MJO. It makes its way around, pretty much falls apart, and then regroups again in the Indian Ocean, makes the same cycle again. All right, the heavy dot right here is where the active phase is right now. So in the East Indian Ocean, the stronger it is away from this circle, or the further it is away from this circle, the stronger it is. So we'll say a modest active phase of the MJO, forecast moving to the far, far West Pacific 2 weeks from now, and pretty weak. This per the statistic model. The dynamic model suggesting the same thing, maybe the active phase making it deeper into the West Pacific, but even weaker again. So both models more or less in sync. The upper level model showing areas favorable for precipitation. Greens favorable for precipitation, reds and oranges not. This goes out 40 days. 8 different panels. South America there, Central America. 0 is the equator. Dateline roughly there, New Guinea there, Australia there. Greens, wet air moving into the upper atmosphere starting today, getting a foothold in the West Pacific on the 25th of March right there, making its way across the Pacific and into Central America on the 14th of April. So about a 3-week period, something like that. And then a pretty strong active phase following after that, again, about the 14th of April, making its way across the Pacific to the end of April, and then another active phase starting to show up in the West Pacific about April 24th, 29th, something like that. All right, next up, output from the CFS model. This goes out 1 month, depicting the east-west component of the wind at the 850 millibar level. That's up about 4,700 feet, but a good proxy for what's going on at the surface. Again, the whole planet on one chart. Now, this is a little bit of a not quite as optimistic a view of what's going on. But again, let's see. Far East Pacific at 130, West Pacific at 135 East, going right up the line there. And then the Kelvin wave generation area ending at 170 West, so right about there. You can see the blues, easterly anomalies in control for today, but in about 2 or 3 days, they start fading. You also notice here this solid contour. This is the active phase of the MJO. You can literally see it moving from the far Indian Ocean today, slowly making it to over the maritime continent and then into the Pacific and then over toward the Atlantic beyond that. And when it crosses the Kelvin wave generation area, you see the emergence of westerly anomalies for, well, these are 1 week periods, so for about 1 week. And then you see the inactive phase, or at least little weak signals of it, starting to make its way across the Pacific in mid-April with easterly anomalies, again returning to the Kelvin wave generation area. And then, if looking out a month isn't enough, we can look out 3 months. The 3-month CFS model, same deal, east and west component of the wind, are the yellows are westerly anomalies, the blues easterly anomalies. What's happened in the past is down here. The forecast is up here. Dateline runs right up the middle. Kelvin wave generation area starts about 135 east, so right about there. And the Kelvin wave generation area ends about 170 west, so right about there. What you see is lots of blues other than this active phase of the MJO that happened in January. Lots of blues. Here's our strong easterly anomaly event that's happening right now. But in the next week, next 5 days, that's supposed to be all over per this model. And westerly anomalies return to the Kelvin wave generation, not for a week, not for 2 weeks, but according to this, for 3 months. If this happens, and we're within 1 week of it happening, this would be a significant change. All right, let's overlay the MJO. All right, so what's driving all this? Well, the solid contour is the active phase of the MJO. Notice the difference. This is a more sensitive model than the last one we looked at. It shows a broader, more lumbering, stronger active phase of the MJO making its way. In fact, it's already tried to make a push into the Pacific, got pushed back, 1 more day of retreat, and then it's all forward from there and continuing the whole way through into May 15th, active phase in control with westerly anomalies. Basically, just stomping on easterly anomalies and pushing them completely out of the Kelvin wave generation area from here forward. And even notice this is the next incoming inactive phase of the MJO. Even as that does its thing, westerly anomalies prevail to the date line's right there. So pretty much the whole Kelvin wave generation area covered through June 17th. What's driving this? We look at the low pass filter. Here we go. Okay, so what are we looking at? This dotted contour is a high pressure bias, the La Nina indicator, and it's still barely in the Kelvin wave generation area. It's really focused about 150 west, so at a point south of Hawaii. You can see little bit at a time as we get into the next 3 months, it starts moving off to the east, and a second contour here, it holds, but it loses ground as we get into May. At the same time, this solid contour here, this is a low pressure bias, just sort of a general tendency towards low pressure. It's centered today over the maritime continent, but you notice the leading edge of it is forecast to slowly work its way into the Kelvin wave generation area and at the end of the model run, almost fill the entire thing to about 175 east. Now, and that change is supposed to happen starting, you notice here, this is, I just found this today, January 31st. It hasn't moved 1 inch. The leading edge of the low pressure bias hasn't moved 1 inch since for all of February and all of March. And then in the next 3 to 4 days, it's starting to make its eastward move. We'll see if this happens. I'm not holding my breath, but if it does happen, and this model even halfway verifies, that will put us in a much better place than where we are today, long term, in terms of looking at storm and swell generation and rainfall potential, not necessarily for this winter, but for next fall and beyond. So that sets us up for the El Nino, La Nina portion of the discussion. First off, we're going to look down in the ocean. What's currently going on in the ocean? West Pacific here, East Pacific here. This is data, again, from the TAA buoy array. The buoys on the equator are anchored to the ocean bottom. Here are the anchor lines. You can actually see some right there, there. You got it. The X's are the sensors on the anchor lines. The sensors collect data, use a model to fill in the gaps. Notice this part of the array right here is completely down, so we're not sure what's happening there. But we can look at absolute temperatures. These are temperatures in centigrade. So the 28-degree isotherm here, it's actually backtracking, suggesting easterly winds are stronger, pushing warm water back towards New Guinea and the maritime continent. This was at one point over at 180. In the past week or two, it's retrograded back to about 171 east. The 24-degree isotherm still pushing the whole way across the Pacific. This winter, it only made it to 40 west, so things are much better. The 25-degree isotherm right here was right up to the surface even 3 days ago. Now it's starting to settle back down, suggesting warm water, at least some degree, is building or at least stabilizing here in the East Pacific. Here's anomalies, differences from normal for this time of year. So here is part of the problem, the paradox that's going on. We have warm water building. This is down at depth, 150 meters in the ocean in the West Pacific, 3 degrees centigrade above normal. But you see, so there 2-3 weeks ago, this was all connected, one long warm band the whole way across the Pacific, a Kelvin wave driven by the active phase of the MJO that occurred back in January, producing or reducing trade winds, producing west anomalies, taking this warm water, pushing it east, pushing the whole way across the Pacific. The last lingering bits of that Kelvin wave are right here in the East Pacific today, but in between the two of them, again, cool anomalies building a little bit. The question is, how long will they build? How much will they build? Will they get a foothold in? NOAA says the atmosphere and the ocean are well connected and not in a good way, in a La Nina way. So if that were the case, the expectation is this cool pool will build more over time. A higher res version of using the same data suggests, well, here's our warm pool, locked 170 west, brick wall there. There's our cool anomalies building between 170 west, that's nearly the date line, to about 110 west. Here's the last little bits of our previous Kelvin wave pushing into Ecuador in that area with the cool pool in between. Sea surface height chart. These are our temperatures as the height of the ocean. Is it higher or lower than normal? That's important because, well, cold water at depth contracts. If it contracts, then it'll make a divot on the ocean surface. This is satellite data. So you strip out the wave heights, the wind waves, the tides, and is the sphere of the ocean higher or lower than normal? Well, we see, let's get ourselves oriented. Chile here, Peru there, Central America, Hawaii right there, equator there, dateline there, New Guinea right there. You see positive anomalies. The ocean height is higher than normal here. That means that there's probably warm water at depth here. That probably means that trade winds are blowing strong for the east, scooping out surface water and piling it up and holding it there. Okay? But we also see a little bit of positive anomalies along the stream here pushing into Ecuador. That's that previous Kelvin wave we were talking about. The last little bits of it are right here off of Ecuador as we speak. The Galapagos are right there. And then we have this -5 to -10 centimeters anomaly south of Hawaii. This is that cool pool that's trying to rebuild. The question is, will it rebuild? How much will it rebuild? Or will it stall due to the low pressure bias starting to move? So the edge of that low pressure bias is somewhere like right around here. And as it starts moving further west to, well, actually it's back here, sorry. It's about 150 east right now. We're trying to get it to move to about the date line. If it does that, that will slacken the trades in the entire Western Pacific, and you'll see this warm water here starting to move, filling a larger portion of the Pacific, and that would be the demise of La Nina. But that is probably optimistic thinking at this point. Upper ocean anomalies. This is just the Pacific. West Pacific here, East Pacific here. Time. You can see last spring, 1, 2, 3 Kelvin waves took warm water, pushed it, driven by the active phase of the MJO, pushed warm water the whole way across the Pacific, and then the whole system just collapsed. Trade started nuking again, developing a nice cool pool, filling the entire Eastern Pacific, peaking about mid-October, and then in December, early January, we had that active phase of the MJO, created another Kelvin wave, and now here comes the, again, building cool waters. How much will we get? We don't know. Ocean surface temperature anomalies, differences from normal for this time of year. All right, so this is kind of the good thing. You look at South America, Chile there, Peru there, Central America, Hawaii there, the equator's roughly here. The clear, cool signature of La Nina that's been in play for 2 years now, still in place. But we have this building area of warm water off of Ecuador and the Galapagos. That is the warm water from the Kelvin wave that is erupting there now, bleeding, erupting up to the surface, getting caught by the trades and starting to drift off to the east. But we know from looking at the previous charts, there isn't a whole lot of warm water left. The expectation is over the next 3 to 4 weeks, this will slowly start fading. The question is, how bad or how much will cool waters build in its place? And by that point in time, remember, the active phase of the MJO is to be pushing over the Kelvin wave generation area, suppressing trade winds with westerly anomalies supposedly building in. So even if this fades, will the cool pool subsurface build more, or will it stagnate, or if anything, fade? That's the million-dollar question. The sea surface temperature trend. And this is probably overhyped. We found some other data, but still, it shows warming temperatures. So here's the equator: South America, Central America, U.S., Hawaii, the equator running right along there, date line right there. You can see the yellows, oranges, warming temperatures, and it's really on the equator we're only interested in. All the rest of this, kind of forget that for now. It's right here. This is that Kelvin wave erupting to the surface, warming temperatures the whole way out to a point south of Hawaii as of right now, with no real sign of any cooling anywhere near. That's a good thing. And then the backed off view one more time. Warming here off of Central America, making it the whole way to a point south of California, almost to 120 west. That's pretty good. I mean, that actually looks encouraging. If we knew there was another active phase of the MJO developing, which we know is happening, and if we knew that westerly anomalies associated with that active phase were going to be strong enough to create another Kelvin wave, then we might think, and it takes about 3 months for a Kelvin wave. It gets generated here in the Kelvin wave generation area, West Pacific. Takes 3 months to make its way across the Pacific, but that would be 2 Kelvin waves in a row, theoretically, which theoretically, if the low pressure bias is moving further east at the same time and trades are diminishing, that would set up the demise of La Nina. The question is, will that happen, or will somehow trades start raging again, and the model we just looked at was a little bit overhyped, and westerly anomalies aren't going to move, and the low pressure bias isn't going to move into the West Pacific, and that would set us up for a third year of La Nina. We've talked about that the last video. Go take a look, but we're not going to rehash that all tonight. Sea surface temperatures in the Nino 1.2 region. This is the region right there by the Galapagos and Ecuador. Pretty warm, half a degree, 567 thousandths above normal. That is today. They were up a little bit higher than that, maybe 600 thousandths of a degree. Still warm. Yeah, better than being down here on the cold side. Any warm temperature will take it. But that's the Nino 1.2 region. The official El Nino monitoring region, the Nino 3.4 area, that's the area south of California on the equator out to about the dateline. Temperatures just noodling around 873 thousandths of a degree, 3/4 of a degree below normal. You have to be half a degree. If you're half a degree or more below normal for 3 consecutive 5 months periods, that's La Nina. You have to be above this, above the half degree line for 5 consecutive 3 months periods to be in El Nino. We have quite a long ways to go before there, and there's no indication whatsoever that we're going to get to El Nino. We're just hoping to maybe get somewhere closer to neutral in the next 6 months. All right, what's going on in the ocean? Remember we said something about the ocean and the atmosphere were coupled. Cold water in the ocean and strong trades and dry air over the Pacific. That's a coupled ocean atmosphere favorable for La Nina. Likewise, westerly anomalies, warming ocean temperatures, and moist air over the equator is the signs of El Nino. We don't have that happening right now. Now, another one of those coupling indicators we can look at is the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Darwin, roughly in the Indian Ocean. Tahiti, certainly in the central South Pacific. There's 2 long-running, they've been measuring pressure in both these areas for 100 years or more, so a long-running record of the variation in pressure between Darwin, Australia, and Tahiti. When the pressure is lower in Tahiti, the index goes negative. Today it's positive at 16.32. Scanning down for the past month, nary a negative reading to be seen. The 30-day average takes some of the noise out of that. Today, 13.28, and you can look at the trend. Well, we were at 10. We dipped down to 7 about the early part of March, and now we're back up to 13, suggesting the inactive phase of the MJO building strength. We know that is the case from looking at all the other models. Theoretically, the change is to come into about 5 weeks, and then maybe this will start going negative. Maybe, just maybe. The 90-day average, it's just a 90-day average of all this. The current value, plus 8.69. Looking back, we've been in the 7.5 to 8.5 range for a month now. Nothing too out of the ordinary, suggesting a weakly coupled La Nina pattern in play. Here's that 30-day index on a graph so you can see last time we saw negative readings was January of 2020. In July of 2020, the index started going positive. These are the active phases of the MJO. These are the inactive phases, the downward versus the upward. Upward inactive phases taking control got us to our first winter of La Nina in 2021. We settled out a little bit last summer, but then back upward into July and beyond. The trend, you can kind of draw a line through that, continues to be upward, just like this trend was upward, but not as high. We're at 15 roughly today. The question, and we're past the historical peak. I mean, typically the peak of La Ninas happen in the January time frame. So the question is, how much higher will this go? Probably not a whole lot higher, especially given what we've seen long term with the models. Forecast sea surface temperatures for the Nino 3.4 region, the official El Nino monitoring region. Well, today we're somewhere down at the temperatures are minus 1 degree or so, about what we saw on the previous charts. The forecast, this is the raw data, has temperatures falling down to minus 1.45 degrees in the early part of May, and then starting to slowly work their way up to about minus 1.25 degrees even into November, which is still clearly La Nina. Now, this is raw data. The PDF corrected data, which is probably the more accurate, still suggests temperatures hovering right around minus 1 degree for the foreseeable future, almost the whole way into mid-December of this year. Still clearly in La Nina territory. Half a degree is the cutoff, nowhere near there. The question is this model wrong? Is it overhyped? That is the unknown. So right now, wind swell in control of California. Small dateline swell working its way towards Hawaii. Better dateline swell forecast over the coming week, but lots of wind still for California, so it's going to be this combo mix-up mess. The good news is the jet stream is showing it dipping towards California, trough off the coast, possible precipitation later next weekend, maybe some swell. So all these things are looking reasonably good short term. And then you even go a little bit out beyond that. There's almost a sense that maybe we'll get into a pattern with the active phase of the MJO, the final active phase of the MJO for this winter, setting up, taking over the Kelvin wave generation area, maybe feeding energy to the jet stream, maybe fueling more troughs, more swell, pushing towards California and Hawaii, though it's getting to be a little bit late in the winter. Clearly, it's springtime now, and you just get the sense in the air that no big event's going to happen, no major precip dump or anything relative to California, but we'll take anything we can get. Looking out beyond that, then we get into the debate, well, temperatures are warming on the equator down south, but that's from a Kelvin wave that is almost over. There is the active phase of the MJO supposed to be setting up here. Give it about 3 or 4 days, and then we're turning the corner. And theoretically, according to the CFS model, from here forward, it's westerly anomalies, low pressure bias moving east. I mean, all those things sound good. But then the same model also turns around and says, well, sea surface temperatures are supposed to be below normal. So there's even inconsistencies within the same model as to where we're going. NOAA, their official forecast, we talked about this last week, but that hasn't changed a whole lot. Still just a giant question mark. We're moving into the spring unpredictability window. The models by default have a hard time understanding what's going to go on in the April-May time frame, and they don't settle out till June. So for now, and there's nothing, looking at everything, it's a real mixed bag. I mean, some pieces of data look positive, like, hey, maybe La Nina's over. Others say, well, the atmosphere is really coupled and it doesn't look like it's just going to break down anytime soon. So there's really no prediction to make at this point in time. 50-50 is pretty much NOAA's guess. We're either going to stay in La Nina for a third year or we'll go into a neutral pattern, which is as good as, just saying, well, we don't know and we're just going to have to wait and see. And that is the honest truth. People want a clear-cut answer. I get it, but life doesn't work like that. All right, so that's it for this week. If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe to get automatic notifications when we post the video, or go to stormsurf.com. The link will be posted at the top of every page of the site when we get the video up here in a couple hours. And other than that, questions, comments, you don't understand something? You noticed tonight we talked a little bit about one of the questions our viewers had. We tried to sprinkle that in if we can't get the questions answered directly on the YouTube page in the comments section. But, write your questions anyway. We'll do our best to answer you. And other than that, that's it for this week. We will see you next week. Same time, same channel. Thanks for watching. Stay safe. Get some waves.